Here's a problem with a frame. So you can see we have a collapsible frame here, right? If I take away the pin support here and replace it by a roller, for instance, this whole thing would kind of squish up, down, and fall apart. So we know that we'll have too many support reactions to find them straight away from the main system. But let's see what we have to do. So we're given all this, and we're supposed to find the support reactions and the pin. We're supposed to give any relevant free body diagrams that we're using. All right, let's start with a free body diagram of the entire system, even if it's not going to give us all the answers. Something like this. We know we'll have support reactions. Over here we'll have a X and going upward a Y. Here we have BX and BY, and then we're going to have our two loads. Load here of 100 kilonewton and a load here of 50 kilonewton. Now, as we already suspected, right, we can't get all of our support reactions from here because we have 4 unknowns and only 3 equations, so we'll need a second free body diagram. So let's put a 1 in here, and then basically we can choose either of the two. Right? I think they're both going to be about the same, so let's take one on the left for no particular reason. So we'd have that here. We have our 2 support reactions down at A, so a X and a Y. We'll have the pin up here, the force of the pin be BX and BY. We're choosing whatever direction we want to. And then we have our load coming down here of 100 kilonewton. This will be our number 2. And now we have, let's see how many unknowns. We have the 2 at A, the 2 at B. Those are not B, those are C. Good that we noticed that in time. So that would be CX and CY. So that's 1, 2, 3, 4, and then at B, 5, 6. We have 2 systems where we get 3 equations each, so we get 6 equations. Should be able to solve this. So let's start. Can we start with any of these? No, right? Because either of those, sum of forces are going to have 2, sum of in X and Y will have 2, and the sum of moments are going to have 2. So let's go back to 1. So let's say from 1, what do we get? We can do a sum of moments around A that's only have CY. Let's do that. Sum of moments at A equals 0. What do we get at A? The next one I get is the 100 kilonewton. They are turning clockwise, so minus 100 kilonewton, and that was, let's see, 3 meters. Times 3 meters. Oops, that's not the one we're looking at. This is the one we're looking at. Then 50 is also going clockwise, so negative, and that is 3 plus 3 is 6, 10. Minus 50 kilonewton times 10 meters. And then the only other thing is CY, because CX, the line of action, is going to go through A. So CY times 14 meters, and it's positive. So plus CY times 14 meters. Only unknown is CY, so we can easily solve. CY was positive, so we flip all the signs. So we have 300 kilonewton meters plus 500 kilonewton meters divided by CY was 14. That'd be 800 kilonewton meters. 800 divided by 14, that's probably not going to work, but we can at least divide by 2, so it'd be 400 divided by 7 kilonewton. And if I put 400 divided by 7, I get 57.143 kilonewton. Cy positive, positive upwards, so acting upwards. Be my Cy. So then also we can get, if we have Cy, we can of course also get Ay in exactly the same approach. So we'll do a moment around C. Sum a moment around C equals 0. Now of course we could also just do sum in the y direction, but let's do the moment instead. So if I do moment around C, then I get Ay negative times 14 meters. Ay times 14 meters. Then the 100 and the 50 are both turning counterclockwise. So they're plus. This would be 4 is 8 plus 3 is 11. So plus 100 kilonewton times 11 meters plus 50 kilonewton times, if I go back to C is what I'm looking for, then that's 4 meters times 4 meters. That means Ay was negative, so the signs all stay the same. Be 1,100 kilonewton meters plus 200 meters divided by 14 meters. That'd be 1,300. 1,300 by 2 is 650. 650 divided by 7, I don't think there's much there. So that'd be 650 divided by 7 kilonewton. 650 divided by 7 is 92.857 kilonewton. We got it positive. We said Ay is positive upward. So upward it is. Alright, so we have Ay and Cy. Now we can't get Cx and Ax. We can only get a combination of the two. But let's see what we can get from number 2 then. So if we do a sum of moments around B, then we could get Ax because we already know Ay. Excellent, so let's do that. So from 2, sum of moments, what do you say, around B equals 0 equal to Ax is positive, and this is all 6 meters. So Ay times, Ax times 6 meters. Ay is turning, the wrong figure here. Our Ai is turning clockwise, so minus Ay, not Ai, times 6 meters. And then the 100 kilonewton is turning counterclockwise, so plus 100 kilonewton times 3 meters. That means Ax, what we're looking for, to flip these signs, so be Ay times 6 meter, not plus, but minus, we have to just switch the sign, minus 300 kilonewton meter divided by 6 meter. That would be Ay minus 600 divided by 300 divided by 6 would be 50. And Ay was 650 over 7 kilonewton, minus 7 times 50 is 350 over 7 kilonewton. is equal to 300 over 7 kilonewton, and 300 over 7 kilonewton is 42.857 kilonewton. Positive, we said AX positive to the right, so to the right it is. That is my AX. Now if I know what AX is, I know what BX is. So I can just do sum of forces in the X direction, again from 2. Sum of forces in the X direction is equal to 0. Be AX plus BX, that's pretty straightforward. AX plus BX. That means we're looking for BX, so BX is minus AX. AX we just found to be 300 over 7 kilonewton minus 42.857 kilonewton. That's my BX. What else can I do? Well, I can also find By by doing sum of forces in the Y direction. So from 2, sum of forces in the Y direction equals 0. What do we get? We get AY plus BY minus 100. AY plus BY minus 100 kilonewton. That means BY is going to be 100 kilonewton minus AY. 100, that's 100 kilonewton, yeah, no, that's correct. Minus AY, where is AY? 657ths. 657th kilonewton. That means 700 minus 650 is 57th kilonewton. It should be right around 7. So yeah, 7.143 kilonewton is By. Now, not much else we can do here because we have all the forces that are in this. So let's go back up here. The only one that we're missing is Cx, so we can just do a sum of forces in the X direction. So from 1, sum of forces in the X direction equals 0. Not much going on there, so AX plus CX. AX plus CX. That means CX is minus AX. AX is here. It was 300 over 7, so it'll be minus 300 over 7 kilonewton is equal to minus 42.857 kilonewton. That means it's going to the left. And with that, we have all we are trying to solve for. But let's do a quick check, right? We said we didn't use sum of forces in the Y direction here. So we could say 150 has to be balanced by AY and CY. AY and CY. So if I just do these with the full numbers, I see I can get to 150. If I do these, I can write it would be 1050 divided by 7 is just 150. All right, so we get some pretty good news there. Now we didn't draw the free body diagram, but if we just look at this side, right, then we know that my BY would be counting downwards, so BY and 50 should be equal to CY. BY, so it'd be 7.1. 7.1, and CY is supposed to be 57. Yeah, so 7 plus 50 is 57. All right, so it looks like we got some pretty good results. So overall, we're able to find all the support reactions and the forces in the pin by taking this collapsible frame and first looking at the overall system, and then just on the left side here. And that was enough, so we didn't even have to draw the free body diagram for BC. If we would do that, then again we could do more tests to make sure that our results are correct, but the couple tests that we just did here in our heads look pretty good.